Welcome everybody. We're going to start today. There's not really much introduction to be done today because we have Louise, so our very own Louise Bracken, Director of IHRR, who is going to be talking today about water security and...
Yeah, it should be water security. Yes, it's water
yes, and multifunctionality of the water chain.
Yeah.
So, Louise, thank you very much for joining us today.
Yeah, is anyone still here who's expecting Rich Walters? No, because he's gone to a funeral, so hence why I'm standing into the breach rather than you have a gap, really. So this has been quite hastily put together, I should say, for this, to really try out some new ideas. And it's not just me. I've got two PhD students, Pammy Sine and Rebecca Smith. Rebecca's in the room. And also Juliana Fanos, who came on a scholarship from McGill to work with us. So there's their work in there as well. So I'm going to start with a bit of a tour really about water security, because water security and sustainability it's really up there. It's high profile in terms of the news, in terms of research, and it cross-sects really the physical processes, social, cultural, environmental. And this is just one of the relatively recent maps that's then up there to look at water stress that's done by the World Resources Institute. So thinking about all these red areas that are then falling into this band of actually having insecure water supply. So it's out there, it's a global, it's there, it's in the Sustainable Development Goals about abstraction, supplying clean water for everybody as a right. So it deserves looking at really. But for me, there's three key challenges about this. So firstly, what are we defining water security as? And there's huge debate about this. So we're going to look at that to start off really this seminar. And then how do we link that theory with practice and what we're doing to actually manage water? And again, lots of people think of it as sort of natural. It's really not. So we're going to look at actually two different cases, one from the UK, one from India, about what we're doing to sort of manage water and how does that map onto water security. And thinking then implications. A third bit here is thinking through the implications of that for what we think of as security of water, but also then what we think about our management. So it's trying to tie that theory with kind of practical management. And I think we really need to do this if we are going to tackle sustainable development goals. The really nice thing about the SDGs is that they bring those different perspectives together around many issues, not just water, but we can't just understand the flooding or the drought or the consequent, they've got to be merged together, which is what a lot of you are doing on this course. Okay, so what is water security? But just before I kind of come to some of those definitions, it's really important to notice that despite lots of these definitions being hotly debated and argued about, there's again loads of stats out there that says something like 80% of the world's population faces a high level of water security. So that's being widely used, widely fundamental to SDGs. But how can we do that despite not having a clear definition, which is quite interesting when you think of the rhetoric of science and how it's being used. And also then that there's multiple approaches to then trying to think about water security. And how do we then go about reconciling these very different views as well? So in general, this is probably what most people think of water security being, I suppose. So something about maintaining acceptable levels of water-related risk while balancing support for livelihood, human well-being, socio-economic development and ecosystem functioning. So that's sort of the generic, all-encompassing definition. So when we talk about 80% of the world's population facing a high level of water security, are we meaning that definition, or are we meaning slightly different elements of that definition? So if we want to dig deeper into what these definitions are, some of these are quite long, sorry, so I know you'll get the slides and the recording. So there's really three types of definitions that are amalgamated in that generic overarching one. So the first one being this one, thinking about that every person has access to enough safe water at affordable costs to lead a clean, healthy, productive life, and protecting the natural environment. So this one very much puts the people at the heart of it, to understand, and that everyone has this right. So you can see this maps directly onto most of those SDGs about people having the right to clean water. The second sort of suite of definitions is much more, well, it's slightly nuanced here. So it's, again, you've got the quantity and quality of water in there. You've again got the kind of health of the ecosystems and kind of natural kind of processes in there. But here you start to get water-related risks. So if we are thinking about the level of water-related risks here. So here they are meaning both flooding, both drought. So you want enough supply, but you don't want too much supply, and you want enough supply all year round. And then the third take on this is that you suddenly, in the whole of this language, you start bringing in then capacity of a population to safeguard access, sustaining livelihoods. You've still got well-being, you've got socio-economic development in here, plus protection. So this starts to be a much more detailed and all-encompassing definition. So you can see that if you think about these, the first one very much encompasses the social needs. The second one starts to encompass and bring in the natural hazards. And the third suite of definitions here starts to bring in the idea about governance and how we're managing this. And if we're bringing in governance, we're starting to have to think about what decisions we make, how do we justify them, how are they equitable, are they prioritising different people, different knowledges. So these are quite different. And they, if you roll out these different definitions, you're going to roll out a different interpretation of water security, and you're going to roll out a very different interpretation of management and practice. So it sounds quite simple, but it's really, really complicated. So we've got debate, we've got complex definitions. How do we then put these into practice? Well, the first step of this is thinking about the conceptual framework. So how do we turn these definitions into something we can think about? And this has really been done in two ways. What you will see as we're going through multiple definitions, coming down to probably two different main approaches. Within these, you've possibly got 3-4 examples of each. So we've got a funneling of kind of ideas. So we've got human development approach, as it's been called, and a risk-based approach. So if we think about the human development approach, this really, again, revolves around people, as it says in the title, and it's thinking about achieving specific outcomes for those people, through whether that's through policy, reform, investment, and it is thinking about the core qualities of water for people living their lives and their well-being. So whether that's about health, sanitation, whether that's then about producing goods, but really it's wanting people to live in a sensible way, really. So how have people map this out? Now what we get then is a couple of interesting conceptual diagrams, which are pretty straightforward, really. So in this first one by the Asian Water Development Group, we can then see that they're trying to balance, they've got a nice diagram here, and they're trying to balance out different elements of what water security is. So we've got the household in there, we've got the cities, we've got the environment, we've got resilience to disasters, so looking at both threats of drought and flooding, and we've got something about economics in there. And all of these come together to hopefully think, and this is quite interesting there, that they're talking about national, in the heart of that diagram is talking about national water security. So, but again, what about the geospatial differences and at different scales within that? Within a single country, you can have water-rich areas, water-poor areas. You can have people at risk of flooding and others that are absolutely fine. So it's not, maybe country level might not be good enough. The next sort of way this has been conceptualized is, again, thinking about a spider diagram, literally, markings on there. But again, a similar type of factors in there that should be considered when you're starting to think about water security. So this one's quite interesting because it starts to think about the relationship to, we've got, water resources, but we've got food, energy, climate, human communities, and actual national security, which is often forgotten about. Water and polluting supplies, there's a huge opportunity for terror around water. But again, all-encompassing, doesn't really necessarily mention anything about scales, but trying to think about all those factors that come into trying to understand water security. The third example about this, and there might be a few others out there, but these are the sort of big three that you'll find if you start looking through the literature. A bit more complicated, but again, thinking about security of water as opportunity versus risk. So thinking about the risks around hazards, thinking about opportunities around the social, the economic and environmental, but puts this right with the growth, well-being and wealth at the heart of it. So you can see this is more of an OECD type of definition, but also thinking about use, thinking about destructive. So it's got a bit more information in here. And it's quite nice. I mean, I think this sums it up quite well. But again, it's fine as a conceptual model. How do you then operationalise it to do something with it? So the alternative approach is thinking more on the risk-based approach. So we have got kind of this tries to include the human and the social embedded risks, but also the water pollution and the natural hazards. But it links more about how societies then cope with the uncertainty and copes with that risk. So we are thinking about exposure, vulnerability, and trying to see how people can be affected differently in different locations. So tends to come down in scale a bit, tends to increase in complexity. And OECD have probably the best example of this in terms of their water security framework. So again, it's all-encompassing as we read those points, that it focuses on achieving and maintaining levels of risk, and it splits those around shortage in terms of droughts. Also sort of lack of supply comes into that, so it's not just natural, there is something about management and interventions in processes. Quality's in there, excess is in there, and then also the resilience of ecosystems. And this is really the first diagram then, that if we've got something around managing it, we've got something about targets, and we've got something about knowing, so something about making those assessments. And this is the first diagram that starts to actually put in practice, so starts to assume and understand that we are actually playing around with our water flux, making decisions about what we do with it, and then so we do get these feedbacks. And that water security framework again is widely used in policy, in theory, and sort of in the rhetoric about constructing the arguments around water. So, but that's about it in terms of conceptual models. So the next level is, how do we then take a conceptual model to do something in practice, to operationalise it? So this of course is crucial if we want to use an understanding of water security to inform any of our management and what we might want to do with our water flux. And as you've seen from the definitions, going through then to think about, then those conceptual models, they can be done in many different ways. And in constructing those conceptual models, we are making certain choices about what data, what we include, what we don't include, who are we putting at the heart of it. We've had a national index at the heart of one conceptualisation. We've had kind of wealth at another. So what's the lens? Why? What's the lens and what's the purpose of looking at water security? But also, this understanding is really at the heart of then how we make the interventions about our water resources. And you'll see that through the two examples we're going to go on to. And really, when you trawl through all the literature, you can only find two models that have then been operationalised into doing something, producing a usable index, if you like. So these two then really are the Asian Water Development Outlook and their National Water Security Index, and then Gain and colleagues that have come up with an alternative. So the National Water Security Index, and this is probably the one that's got more mileage so far with what anybody has developed. And this is quite, I would say, quite an elaborate example of security, of water security assessment. It is based on publicly available data. They want this to be, sort of clear for people to interrogate from their own purposes. And it can be applied at different scales. So you can work at the country level, but you could actually come down to sub-catchments and even city levels, which is quite useful. And again, the idea is it's there to support decision making in a transparent way, and that's how really the authors have wanted it to be used. And what it then does is it aggregates indicator scores, and we're going to look at those indicators in a minute, to then come up with this one overall index of water security. So it's quite usable, particularly to look at comparisons between, you know, different areas, whether you want it to be countries or you want it to be regions within a country. And there's 5 key dimensions that it looks at. So again, you can see that this maps onto some of those conceptual models of water security quite well. So it looks at the household level, economics, urban, environmental, and resilience to disasters. Now each of those they then give a score to, some of which might be slightly subjective, but at least it's giving you a relational table that you can, you know, hopefully see which areas might be suffer with water security compared to others. And you come up with a table like this. Now this is taken straight out of their publication. So each of the columns here is kind of factoring onto one of these key dimensions. So 1 here is households, 2 economic, 3 urban, and so on. They obviously they've evolved this as they've tried and practiced it. But really, you come up with, this is an example where they've done it for a whole list of countries, and then you can come up with a score for those different countries, which again, they then even simplify further into thinking about an index. So, very good relationally, and very, you know, a nice metric. Lots of people making decisions and policy and deciding interventions like a number that they can get hold of. So it does give you a number that you can then apply. So the second model then is thinking about, or is called the Global Water Security Index. So some of these bits are quite similar. It's a spatial multi-criteria analysis, so that's similar to the first one. Again, it gives you an indicator value. This works though on a pixel by pixel basis, so you can kind of think about it at different scales, and it does sort of accumulate that data. Again, it's supposed to be used for monitoring targets. It really is there to speak to SDG 6, so that is the one on availability and sustainability of management of water and sanitation for all, and that for all bit is really important in all the SDGs. And it tries to think about the spatial and temporal performance. So rather than just being kind of one moment in time, it tries to think about that. And it has the 4 main criteria that are up there. So we've got availability, accessibility, safety and quality, and management. But what is interesting is then that they've weighted these. So availability is seen as the most important, followed by accessibility and safety, and management. And some of these could be hotly debated, as you might want to later. And as some of the critiques of this would say, what's the point of weighting this availability if it's not of a sensible quality? There's again different arguments for management, or can you clean your water? So it does become safe, but that's quite interesting as well, that availability is championed, and it doesn't maybe matter whether it's clean or drinkable. And then they assess lots of different aspects to them. So they come up with quite useful diagrams like this. So again, this is then showing it at a country level, and you can work around these diagrams quite nicely, and you can start to see. It's very hard to see from here. I haven't got my glasses on, which is, so I can't read this and I can't see that. But you can start to see, if you look at, say, Bangladesh, it has a very different pattern then, and gives you certain clues about what we think are important for them, versus, say, somewhere like India, which only really falls down possibly on groundwater. But also then this second diagram here kind of then rates out these 4 sort of main components over it. So again, it's quite interesting, and it does really highlight some of the issues that you then might want to act on in terms of management. So, but a very different way of presenting data. But that's it in terms of understanding water security. There's lots of data, there's lots of research papers that kind of say, actually we're fine, we've got enough water resources on the globe, particularly if we start thinking about groundwater, not even touching oceans, which is a whole debate in itself. But it's based on these definitions, these debates. There's only a few conceptual models, and there's even fewer ways of operationalising this. So why is this good enough to make the statement that actually around the world we're actually secure for water? I would hotly debate that. Yeah.
Sorry, just quickly, you mentioned that these use publicly available data. So is there a sort of political bias in some of these developing countries that fight over water? Is that factored into these security indexes?
Probably not at this level, I don't think so. But yes, whether that data is accurate and what scale that data is available at is an interesting question. I don't know whether anyone would not release accurate data, and I think lots of it might come down to other composites that kind of come through the World Bank or WHO. So I'm not sure at that level I don't know, is misused. It might be, but I think at country level. But I mean, I think the big challenge is getting the data. But the point is, they're using data that's in the public domain, so you could question that. You might be able to, do your own analysis on the ethical considerations of that data. Okay, so the challenges then. I think some of the challenges that I'd kind of think about there are that yes, we've got weightings of criterion in there. We've got choices of criterion, and again, some of those might be driven by what data is actually out there, and what you can get hold of, rather than what we ideally want. That's always a challenge with trying to come to any metrics. One big issue is this is a snapshot in time. You create it for a time period. And you'd have to create it on multiple times to then map any of the changes in this. But it's quite interesting how you can kind of learn, or whether you can forecast what's going to happen. But they're not, they're not kind of ready for that use. Scale is hugely important, because at what scale do we want this knowledge? I mean, it's very interesting to do it at a country level. Does that really help the decisions about how we manage our water flux? I'm not sure it really does. What do we do about boundaries in this? How do we move our water across boundaries is really interesting, be it natural processes of a flood, or be it in our manufacturing process. So that's quite complicated. And then the big issue that I keep coming back to is, how does this map on to practice of water management? Are we making decisions about water management that think about water security, or not? And at what scale do we make those? So we're going to look at this relationship a bit more now. So what we're going to do is we're going to look at 2 case studies. The first one's going to be interbasin water transfer in India, so looking at a relatively big area and a large case study. And the second one, which is Rebecca's work, who's up the back there, is thinking at a more local scale, even in the UK, about how we make some of these decisions. So this is really drawn then on very physical research. So interbasin water transfer in India. Now, I should start by saying that IBWT is a massive exercise that's going on around the world. It's not new. It's been going on since ancient times, with canals, open canals to transfer water around. What is happening though is it's entering a whole new scale of working. So what India want to do is they really do want to take it from what they think are surplus areas to then give to possibly drier areas. So, ensuring access to all but also ensuring access to wealth creation for business. So there's a map up there of India, and these are all the proposed links that they want to make at the moment. So there's quite a lot. That's quite a massive cost, and that's quite a massive amount of water that we want to transfer around. And then the Interlinking Rivers project in India is just one project, and even that project itself is made of 30 different links, and that are kind of within states and 32 between them. So it's massive investment, it's massive decisions. And then what Pammy did for her PhD, and she's just got her PhD, is that she's explored one particular link, or two links I should say, that will function together. So she's explored how these would function, and she's kind of critiqued the decision-making process in this as well, which is quite interesting. We're not going to go into all of that today, but what we are going to look at is a bit of the research that we did through that. So this is then the study area. I've lost my pointer. So we're down here in India. She's looking at kind of this scale of it. So it's a relatively large catchment when you're dealing with a couple of 100 kilometres across each way. And what she's then done is we've got 6 basins that she's really looking at, and these ones in red are really what are going to work and propose to work as the donor catchments. So there's the areas where the sources of water are coming from, and the green areas are then the ones that are designed to then receive what is presumed to be this excess water. And we can see then the links where these rivers are going to be, and they're going to be new channels that link basically existing rivers. And nice pictures that are used in lots of then the information that we make the donors look kind of lush and green, and we make the recipients look barren and dry. And then, so what we've done in the research that Pammy's really led is we've actually gone back and looked at the hydromet data to see what the sort of rainfall river regimes are, whether there is enough water to transfer, and we've looked at that at different time periods. The initial kind of work that was done off this, the feasibility study, only looked at annual data. That in itself was a problem, because then you're not looking at the monsoon and the non-monsoon season. And really, it didn't really look either at the demand for water either. It just looked at, we've got these wet areas and we should transfer this water to the dry areas. So here we've got a simple diagram looking at our daily discharge in our rivers. And as anybody who's looked at physical data will know that we're looking at quite a big area, and we're just picking one location to look at the stage data. Again, as you look at bigger areas, the quality, the amount of data sort of goes down. But this was really showing that even across the donors at the top and the recipients at the bottom, the trends are pretty similar in terms of discharge in rivers, and not that different. We can then look at this across monsoon and non-monsoon times of the year, and this is done on a monthly basis, and you can suddenly see why the spatiality of your data starts to be important, because again, everything functions well in a monsoon time, so we can see that we've got similar supply in most of these catchments. As soon as you're out of the monsoon, it's a different story. So what are the relative availabilities of water in these catchments? And here we just pick two examples here of a donor that would lead through to a recipient, so the donors in brown and then the recipients in green. And again, it looks, at this stage, this top graph here, it looks like it's all possible, really. But you only start to look at these bottom diagrams, and we've got the before and after with the link. So there's a lot of modelling that goes into being behind these diagrams. So we've got kind of without the links, and then with the links in both the donor in the brown and the recipient the green. And you can start to see that through some months of the year, particularly in the monsoon, this all looks all right. And we look like we've got a lot more water in the donors compared to the recipients, and there's only a very small change with the linking. So it all looks like it's possible, and you think, well, that's fine, we're just distributing our water around and everybody's a winner. when you suddenly then start to look outside of monsoon, you start to get months even, where there isn't enough supply. And these are then the problematic areas, because what do you do? Is this still a sensible decision to be transferring this water? Is it equitable? Is this supply for all? Are you benefiting some people down in the recipient catchments here compared to and wrecking these source areas? So this starts to raise questions, and if someone has only done their analysis on an annual time period, they wouldn't get this difference between a monsoon and a non-monsoon, which is fundamental and possibly obvious. But again, it's what rules have you set up to do that sort of feasibility study to see whether we've got enough water? What data are behind this? I mean, the work we've done, we again have tried to use publicly available data, and we are going off stage data, rainfall, in terms of looking at the hydromet temperatures to work out evapotranspiration. We have got a robust model behind this that again it's an off-the-shelf model called the WEET model to look at kind of the transfer, and we can put those links in. And we have estimated demand depending on agriculture that's published, heavy industry, and also domestic. So we've tried to put the same assumptions in, so hopefully this is all as accurate as we can be, and if not, it's relative. And then we can move on and think again about looking at the mean daily discharge. So again, we're coming down in scale, that extra step, so to speak. And again, we start to see a similar pattern. And the top bit of the diagram here is then thinking about the monsoon season, and this is then the amount of water they want to take off. So again, it looks minimal when we're looking in these kind of units and volume. But come to the non-monsoon season, and again, we start to get this different story, and that there's points in the year, and think about here, this is the line for the required water transfer, that the rules that they've set up in the feasibility study. So again, it starts to become quite an issue. So we've got an issue then in terms of managing this water, and maybe the decision making and how it's been designed. But what does this then mean for water security? That actually you're taking this water from areas, they have got social, kind of their own well-being, domestic, but also industry may be set up to work one way, that you're then going to damage, change, probably make worse, but actually where you're actually got the recipient bases, you're hopefully making their situation better. So there's massive ethical considerations in here, and one of the bits of this research is showing that lots of these feasibility studies have been done behind closed doors, so they're quite hard for publics or NGOs to really examine. So there's quite a lot of issues. So IBWT, just to summarise this bit around kind of the practice, has really been recognised as this potential to solve all these kind of water scarcity and the water security problems. But this analysis, even at this level, is really showing that that if you come down and you want, again, absolute figures, on an average, almost 16% of water available per annum in Gamale, one of the catchments, should be transferred, but that's already not viable out of monsoon. And that's not really even working forward what's going to happen with climate change. And we've done some scenarios to model that, and that just seems to exacerbate the situation. And then coming back to scale and these spatial understandings, this spatial understanding really matters at what time, how we want to sort of interrogate what's going on in processes and decisions and use, but also where you take one bit of water out and move it starts to have a massive impact on health, well-being, social, cultural, the whole of our systems. Right, so we're going to move and look at the UK really, and we're going to come down in scale dramatically now. And often what we've seen in terms of the UK is we have surface water management and groundwater management, and often they're kept relatively separate. And what we've tried to do, and what Rebecca's doing in her PhD, is trying to investigate them all as sort of this integrated resource. And in this study we're particularly thinking about what this integration and sort of change means for water quality management. So at the start of this problem, start of this research, we were faced with a problem that came from Northumbrian Water, so that's our local water utility, that we have a borehole here that effectively they're having to blend. So as they take this water out of the ground for abstraction to provide for drinking water supply, it's the wrong quality. So they're having to use other water supplies to blend with it, so it's then of the suitable standard. So they're faced with this decision or this issue, like where is that pollution coming from? And again, we're arguing that to look at this properly, we need to integrate the surface water and the groundwater understanding. So this is a map really including lots of the geology and the faults, and they're really worried that this is the problem, that there's something on this source zone where we've got something crossing one of these faults, or have we got pollution coming from this fault into this one? You know, what's going across the top of this that then magically runs down and creates these high levels of pollution in the water? So we started to kind of investigate this, and then we've been looking at a stream that really comes across the top here called the Harrington Burn, wondering whether that could be the source at that top end for some of this pollution. So this is then a map of that stream, and this is what Rebecca's done. She's gone out, she's been mapping it, taking water quality samples, trying to understand what's happened in its development. And we can do this both from desk-based but also in the field. So initially we start looking at kind of that underlying geology. So what's that geology doing? How's it allowing water to move through that subsurface? And again, we've got limestones where the water will go straight through and operate as a really motorway connecting them, and then other lenses where they're going to stop it in terms of these mudstones. So what Rebecca did is she's then calculated a bit of a risk of connection map between the surface water and the groundwater. So again, we've got red areas where there's quite high risk of connection, where the water can percolate through into that geology, and green areas where it's much better, it's less likely to connect. But we can see if we've got a fault that coming down here, that we can see that what happens in this top end on the surface waters is likely to get into the groundwaters relatively easily. And this is done off geology. What Rebecca then did was then start to kind of put on what was happening with that superficial drift. So does it, where we've then got some of these clays, and really a basic, have we got anyone here that would be a groundwater specialist before I say anything? No earth scientists, no? But some of the people we would work with, or we do work with in Northumbrian Water, who come from a groundwater understanding, and then there's no possible of connection here because we've got kind of this clay that would hopefully block it. But it does matter what thickness that is if that clay is permeable. So we've taken some time to try and understand that, to put new levels of information on that risk mapping. What was interesting in this stream as well is then what's happened with any of our urban development, because when we went out there is a problem in the chemistry. I haven't got the chemistry results on here, but when we did go and sample that chemistry, we have got areas of that river that are relatively polluted. So is that of high enough level to get through into the bedrock to then influence that drinking water supply? So we looked quite carefully at where these faults were lying, and what was interesting at this top end, everyone was saying possibly not, because look, the river starts here, where is it in relation to that fault? But we went and did some field mapping, and we started to look at what had happened to that channel in the past. So that might be the blue line off the map. But if you then went back to kind of some of our more historic maps, and we could see evidence for this in the field, that this is where that stream would have come from. And then in the field mapping that Rebecca was doing, she could still see kind of an unused river channel at the top there. So that starts to beg the question, where's that channel gone? What's it doing? So working through kind of these older maps, which you can get hold of, relatively straightforward, we could then see how the mapping of this channel changes, and it's got shorter basically, and shorter as as you map it to be more similar to where it is now. And then in terms of the field walking and the understanding, and we were then in discussion with Northumbrian Water about this, why has there been such a reduction in surface flow? Is it something about the surface groundwater processes? Has there been a connection through some of those clays to allow the water to completely go through? Or, as we then found out when you're walking up there are some new sewers up there, which initially NW denied all knowledge about. You're going, no, there's a sewer there. And again, then you do find they've got some maps. So, I mean, this whole area is really reclaimed spoil. So there's been some channel shifting as they've reclaimed that spoil and built these housing developments. There's obviously been some changing in kind of capture of this as they do some of these houses. So again, it's a very interesting case study in its own right. As we to look at as an interesting problem. We've trialled a new method there about trying to understand surface groundwater connections, but actually again there's quite big implications for water security. What are we doing with our rivers? How is the surface and the groundwater interconnecting to then change these resources? Okay, we're in a wet area, we might not be worried about supply and access to supply here, but the quality is really, really important. This small stream is quite polluted, biodiversity is failing, it's full of rubbish, it's not somewhere you really want to go and be wading around too often. But again, we're making quite big decisions, and if we have got polluted drinking water from our borehole, then that's not actually great in terms of what we're doing from our resources and when we're thinking through our future demand, even in the wet northeast of England. Other things we have done with that, we obviously can map then some of our runoff, and again we've got that catchment there that's bounded in brown here, that's the water, then we're not sure where it's going, so again that's quite an issue. And interesting in terms of the people that are managing our water supply up there are not, half of them seem unaware of what they've done to the water supply, which was fascinating. So even in terms of the UK, we've got uncoordinated catchment development. It's pretty common. These can have multiple impacts on our resources that possibly not always recorded, and we need to think about how different bits of the kind of water system are speaking to each other and working together. And we've got some problems in terms of quality, in terms of blending, in terms of biodiversity, and just how complex making our decisions of water is. And in the UK, we're very much siloed into surface water versus groundwater, rather than looking at this in multiple ways. So what does water management mean for water security? So these two examples do demonstrate these different scales at which we intervene. So we've had a very large-scale intervention in terms of India, smaller in terms of the UK. There was that question about data. We are making decisions without perfect data. I think practice is often making decisions with what they think is good enough data, but that does lead to questions about making substantial decisions about equitable supply. I still have problems where some of those definitions map onto or incorporate kind of the examples I've been talking about. If we're doing really big management interventions with our water, surely they've got to fit somewhere with those definitions, which is interesting. So that drives me to think, do we need a different way to think about some of this to capture it that could be maybe slightly more useful? And we really do need to think about water as a flux. It's probably one of the only resources that kind of goes on and doesn't stop. We reuse it, we make it dirty, we clean it, it comes back at us. But we do need to think about the consequences on different parts of that flux. So one thing we're trying to do to come up with something different is thinking about what we're calling the water mix. Now, any of you that work with energy know there is a term called the energy mix. So we're wondering whether we can bring this in to think about water. So what I'm going to give you today is not a finished metric about this, but to show you kind of how we're starting to think through this with some other researchers. So how can we use this to think about our inventory of assets, to think about consumption and where we're doing what, and thinking about the different ways in which we use water. So we've come up with what we think is quite simple. So the idea being that we need to think about our freshwater availability and separate it into, and what we've called, again, there's debate about what these should be called, blue, green, grey and embedded. So blue is literally fresh water, either surface or groundwater. Green is the stuff that's stored in the soil, so it's there in terms of in the roots, so it's much harder to get at. You can see the differences about what's usable in this. Grey is probably polluted. It might be, from domestic, that could be reused, could be recycled. It could be polluted water. So it needs something doing to it before we could use it. And then embedded. And so far in what I've talked about today, there hasn't been anything about embedded. So I don't know whether any of you have gone and done your kind of water footprint, that you might do about your energy footprint. But this is like looking at kind of the amount of water that we use to produce commodities. And there's a massive market in this, and if we want to think about water as a flux, surely we should be thinking about, tradable goods, what that does to moving water around. And then we can assess water consumption and usage of these different bits of water in any region, so be that domestic, agricultural, industry, and hopefully then come up with some risk categories to think about what we're doing. So we've worked this through in terms of a couple of scenarios. So the first of this, and the idea here is that we then have two diagrams, and I lost my cursor. On this side we can think about the different types of water and their proportions, and then you can think about how we're using that water differently. So in this first scenario, we've very much got mostly freshwater resources. Some of that is then a little bit's grey, a little bit's green, a fair bit's kind of embedded, but then we can see how we're using it, and we can think about it providing mostly agriculture, some environmental, little bit of industrial, and then pretty domestic. So this might be the type of kind of data that you would envisage getting from an agricultural region that's mostly self-sufficient, and it's pretty wet, it's got its water, it's using it to grow produce. At the other end of the spectrum, this is as far as we've got, is thinking around areas where it's maybe not so clear cut as that, and that you might have half the water might be available, half of it is really then invisible. So how do we get that? That's you're importing it. You're importing your fruit and veg, that's going to contain a lot of water. What about any items you're manufacturing? How far and wide are they coming from? And then thinking about what you're doing in this area, we're thinking about it, again, being mostly agriculture, but this type of then diagram would start to suggest that you are importing more goods and services, so you're drawing on other people's water to supply your needs. It's very simple, but it starts to look at water in different ways, which is what we think we need to do. So we're now at the point where we're trying to play around with data to try this out, really. And I can't give you any results because it's proving very difficult to get the data. But our proposal is that if we work through this, hopefully it would think through water security in new ways and put new bits of the issue up at the forefront, I suppose. So we are going to test for real data, and we are going to test it at different scales. And even in this, we think it's got a pretty explicit recognition of water resource management, because if you even think about the India kind of example, whatever region you're looking at, it would start to be able to say what's kind of coming in. It would be part of that data somehow. But is that explicit enough? From what I've just said about thinking about practice, I'm not quite sure, but it does go a bit further. So if there's anybody that's desperate for a dissertation idea, this could be something that you could come and work with us on to try and test more fully, because it really is about plugging in the data now and seeing what it says. Okay, so to summarise, there's a massive gap between how we're thinking about water security and how it's being used as a rhetoric, between then going to conceptualising it and actually operationalising it. And there really are only those two examples right now. And for all the political discussions that are going on, that's not much to make these decisions of. There's massive geographical and sectoral variations in water management and how these impact availability for people, for industry, for agriculture, generally for well-being. So that is really, it's crucial that we understand it really. I think we really do need to think through these implications of virtual water trade much better. At the moment we don't, they just go on. And if you read any of the literature, say in California, I'm simplifying this grossly, but it's all right for companies to abstract and resell bottled water back to people downstream. It's okay for consumers to grow, kind of really high demand water crops and then export them. Should that be allowed? But I think if we actually had metrics or ways to look at it differently, you'd be able to start to kind of unpick some of those arguments and have the data to think about how those arguments are constructed. And I would really support a systemic integrated approach for thinking about the whole water supply. I don't think we can tackle water security if we only think, like in this country, that we have kind of surface water or groundwater, or we need to think across those and not just regulate for different bits of water use. And that we need to think about this in all of our development. I think water should be up there, whether we're planning new homes in the UK and they're in the right place, through to the whole, like we've seen in interbasin water transfer. And yeah, I think we should give the water mix a go. It might get nowhere, but we've got to try these things, I think. And then finally, I think we need to think about this how these sort of supply chains map onto SDGs, because again we had talks from Ben Taylor and the such like before, but we need to think about where these meet to kind of make interventions. And that's it. Thank you. Sorry, look at that one. In case you'll tell me